Guys, to here, rate of change, homework 19, here we go. The formula for rate of change is on page 1 of the reference table. It is right here, rate of change, change in value divided by time. So, in this case, this is what happened here, is the travel time, this is a stream here, and A, this is a point in the stream, something's floating down the stream. For this thing to get from A to B in this stream, the distance is 12,000 centimeters. It took 240 seconds. So the change in value of its location is 12,000. It took that long. 60 says, determine the rate at which the ball traveled in centimeters per second from location A to B. Show your work. Here we go. From the reference table, change in value divided by time it takes for that change to occur. So the change in value here is 12,000, and it's centimeters, must have units on there, and the time is 240 seconds. Okay, so what you want to do is do the units first. Centimeters per second, they do not cancel, they do not simplify, they get carried over. Your units are centimeters per second. They must be on there to be correct. And then 12,000 divided by 240 equals 50. Okay, so that ball during a ball traveling during that time, floating down, traveled at a rate of 50 centimeters per second. Must have centimeters per second on there. If you do not, it is wrong. Okay, 67. This is the carbon dioxide concentrations in Earth's atmosphere, and it's measured in ppms, which is parts per million. Parts per million is what ppm is, and it's one of the ways we measure things like carbon dioxide. So we're doing calculate the rate of change from 2000 to 2010 of the average carbon dioxide in parts per million per year. Show your work. Change in value divided by time. So the change in value from 2000 to 2010 would be 390 minus 370, and that's going to give you 20, and that's ppm, parts per million. The time it takes for that to happen, 10 years. Let's do the units. Okay, we'll just carry them over because there's nothing else we can do with them. It's going to give us parts per million per year, and 20 divided by 10. 20 divided by 10 is 2. Answer. It's been changing 2 parts per million per year for number 67. Now, just to make sure people are doing this, pause it on these numbers here. Pause it. You want to find your letter of your last name. So, for instance, mine is Gazda 35. I will then go here next to my name. I'll do it like right here, 35, and circle it. Okay. So. As just another example, if your name was, let's say, Brent Best, everyone loves Brent Best, you would look for B, number 22, and next to his name you would write 22 and circle. So pause it now, write it down. This is how I know who's really doing this. Gets you credit for actually doing it, because some people are skirting the rules here. Thank you. Here we go. 70. Calculate the rate of change in the outside air temperature from 8 a.m. to 2 p.m. in degrees Celsius per hour. So 8 a.m. to 2 p.m. What am I looking for? Outside air temperature. Outside, so that's key. Right? Outside? Outside. Okay, so the change, let me move it up here. The change in value divided by time. The change here is 18 minus 15. That's 3 degrees Celsius. And the time from 8 a.m. to noon, 8 a.m. to 2. 8 to noon, that's 4 hours. And then noon to 2 p.m., that's another 2 hours. So that's 6 hours in total. So 6 hours. Okay? Units first, everybody. Degrees Celsius over hours. Okay? There's no simplification. It does not get squared, any of that stuff. Degrees Celsius per hour. 3 divided by 6, as you'll see, 3 divided by 6 equals 0.5. So basically 0.5 degrees Celsius per hour is what it's warming up in this case, or half a degree per hour. Alright, we are on a roll. This one here, Look at this pretty sweet drawing that I did, series of drawings. Yeah, I know, pretty awesome. Calculate the rate of growth for the tree shown below. Show the formula in all your math. Express these answers to the nearest tenth. So here is telling you to round to the nearest tenth. That is 1 decimal place. Tenth, 1 decimal place. 1 decimal. Okay, know that. So in this case, rate of growth from 2005 to 2012, 2011. Sorry, 2005, 2011. So change in value divided by time. So the change in value, well, it was 13 feet tall, the tree at that point, in 2005, and now it's 27.5. So the change is 27.5 feet minus 13 feet, okay, which should give you 27.5 minus, what, 13 feet? 14.5 feet is how much it grew during that time frame. And the time from 2005 to 2011, 11 minus 5 is 6. It's 6 years. So then I do that, divided by 6, and it's going to give me, oh, wait, first, you're right. I know what you're thinking. Don't you want to do the units first so that you don't forget? That is exactly true. Your answer will be in feet over years, or feet per year. And then if you look at that, it is 2.41666, but I'm only interested in rounding to the tenths. Mission to 4, does a 4 stay a 4 become a 5? The 1 right there will make it stay a 4. Answer, 2.4 feet per year is what is growing during that time frame. The next time frame is 2011 to 2015. What is the rate during that time? Is it growing the same rate, more or less? So in this case, again, same formula, change in value divided by time. And here I'm doing 36.0 feet minus 27.5 feet is going to give me, what's this, 37 minus, no, I'm sorry, what did I say? 36 minus 27.5 equals 8.5, is that right? Yeah, 8.5 feet. And the time from 2011 to 2015 is 4 years. Okay, 15 minus 11 is 4 years. And do the units first here. You will therefore get feet per year. And then 8.5 divided by 4 is 2.125. And then round that to the tenths, I look at the 1. Is the 1 going to stay a 1 or become a 2? That number next to it makes it stay a 1. Answer, 2.1 feet per year. So it's growing at a bit slower rate, maybe because the tree is getting a bit older, or maybe it's not as rainy, or whatever it may be. But the rate's a bit different of the tree growth there. So this rate of change, maybe not the most exciting thing in the world, but we use it for a lot of different things, so make sure you have that down. Okay, so thanks for watching. I'm Mr. Gadsden on behalf of all the folks at Gazdoni Productions. Thank you.